So hello, can you hear me? While Rachel is setting up, let me just introduce her. Should have brought my glasses. She's the Senior Vice President of Data Science at News Corp, which includes the Wall Street Journal, New York Post, the Times of London, the Sun, and other journals. She's also adjunct professor in the Department of Statistics at Columbia University. She was previously a statistician at Google Research, and she just recently co-authored the book Doing Data Science, published by O'Reilly this year, or actually last year, October 2013. And she has a PhD in statistics from Columbia University. She'll be talking very appropriately about what is data science. Thank you, Rachel.
Thank you. Thank you to the organizers for the honor of the invitation. I'm here to discuss the question of what is data science, which is a question that I've struggled with for the last couple of years. I just started a new role in October as the SVP of Data Science at News Corp, which I'll tell you a little bit about at the end of the talk. I thought a lot about the organizer's title, Weathering the Data Storm, and in particular the promise and challenge of data science. And I thought about it also through the lens of trying to answer the question, what is data science? Because I think there's a lot of challenges in even asking and answering that question, and also promise in asking that question. So some of the challenges, that's formatted badly, sorry. Some of the challenges in answering the question is that there's a lot of hype around data science and big data in the media and on social media. And because of that hype, the term data science is used vaguely and frequently, and it's hard to even understand what people are talking about when they're referring to it. You know, it raises a lot of questions. What is the science of data? A lot of statisticians would argue that statistics is the science of data. Does data science only refer to the science of big data, or does data science refer to the science of any data? What's big if it's big data? Is it only data from tech companies, or does it expand to all types of companies? Is it only in industry, or is it also in academia? And so data science ends up subsuming a lot of other fields and disciplines to the point that it's sort of hard to even understand what the boundaries of it are. It subsumes, in some cases, statistics, machine learning, predictive analytics, data mining, and so it's sort of a challenge to a lot of people who are already operating in these fields to sort of welcome data science, I suppose. And it's also that it's a moving target and ever expanding, so it makes it hard to define. But it also comes with a lot of promise, as Dean Murray alluded to. There's no question that there's a cultural shift in our country going on right now around data and technology, representing that humans are letting technology and machines into our lives as extensions of ourselves. And this has been happening fairly recently, you know, only in the last 10 years or so, 10 years, that just the everyday consumer is willing to walk around with a computer device attached to them. And this wasn't really part of the popular culture 10, 15 years ago. And so there's no question, I think, that something new and real is happening. We may as well call it data science, but you know, still, what is data science? So I wanted to begin to answer. I think it's helpful to look at the origins of data science, and I want to look at them from three perspectives. The first perspective is as a job title. Data scientist as a job title. The second perspective is that of a term, data science. And the third is sort of orthogonal to those by looking at the origins of data science in other academic disciplines. So let me start with the origins of data science as a job title, because I think looking at it this way sort of helps understand where all the excitement came from. In 2008, the story goes that Jeff Hammerbacher, who was at Facebook, and DJ Patel, who was at LinkedIn, had a conversation about their hiring practices and trying to hire the right types of people for their data and analytics teams. And DJ Patel in 2011 wrote about this in an O'Reilly paper called Building Data Science Teams. He says that in 2008, Jeff Hammerbacher and I sat down to share our experiences building the data and analytics groups at Facebook and LinkedIn. That meeting was the start of data science as a distinct professional specialization. We realized that as our organizations grew, we both had to figure out what to call the people on our teams. Business analysts and data analysts seemed too limiting. Research scientist work was done in labs, which were isolated from product development groups. And so the focus of our teams was to work on data applications that would have an immediate and massive impact on the business. And the term that seemed to fit best was data scientists, those who use both data and science to create something new. So I recommend reading more. I think DJ Patel has been really great in a lot of his thinking around what data science is, but I just want to look at then some of the attributes of what distinguished this role based on what he said in that article or in that paper, but also other things I've thought about with respect to LinkedIn and Facebook as companies in particular. First of all, the data that was collected at places like LinkedIn and Facebook is collected about signed-in users who are interacting with online products. And all their actions are logged, and so you have their raw logs down to the timestamp, their clicks, their browsing behavior, what other users they're looking at. And in particular, LinkedIn and Facebook had social network data, so you could observe the relationships between all the users. I'd say one of the key things is that the data science teams that these places focused on were building data products, and this is a key concept that I want to explore a little more. But in particular, at these places, they were building data products that were, for example, friend recommendation systems, and so the products themselves are literally built out of data. The skill set that those teams looked for were this hybrid set of skills, including the ability to write code, to do statistical modeling, and also these teams, and because they were at social networking type companies, valued people with social science skills, so who could sort of understand the human behavior that was going on as expressed in the data that was being generated by the users interacting with Facebook and LinkedIn. And computer science. And oftentimes, they didn't look for all these abilities or all these skills in one person. Rather, they had interdisciplinary teams of people who could complement each other with these skill sets. The personality type, or I should say the personal characteristics they often are looking for are creative, curious problem solvers, and the people who have the ability to tell stories from data and interpret it. DJ Patel is being quoted as saying data scientists should think like journalists. I want to explore a little more the concept of data products, because before LinkedIn and Facebook, of course, there were other companies building products out of data. I would argue, I wouldn't have to argue. Google, for example, they have search ranking, ad serving systems. All of these are examples of products literally built out of data. Spam filters for email, and then a host of other recommendation systems coming from places like Netflix with their famous movie recommendation, and Amazon with their book recommendation. And so even Facebook and LinkedIn weren't the first teams to be building what you would call data products. I'd say some of the attributes of data products are that the raw material of the product is both data and code, and the product is literally made out of data. And I'd say that these data products are oftentimes core to the business. They're core to the business model. They oftentimes, one of the key attributes is there's a feedback loop, which is that the more the user uses the product, the more data is generated, which can then improve the product. And so, the user's interacting with Facebook, you see who they're clicking on, what people they're looking at, who they choose to become friends with, and then that can improve the algorithms underlying their future friend recommendations. Or similarly with click-through on ads or on spam filters and other things, there's this feedback loop that the more the users use the product, more data is generated that goes into the algorithms that then improve the product. But the underlying methods can be familiar techniques such as logistic regression or naive Bayes, or methods that have been part of standard statistics and machine learning curriculum for a long time. But often another attribute is the scale of the data, and the implementation can be a challenge because sometimes these need to be implemented in real time. So I want to distinguish the role of data here between data to build data products and in some products that are automated from the role of data in making business decisions or understanding customers. So, you know, sort of one-off analyses where you're looking at sort of user behavior over time and then you're going to make a business decision about it is very different than analysis. An actual product that's automated and has algorithms underlying it, and the data and it's this whole feedback loop without any humans sort of having to make any interventions. Even though if you're using data to make decisions, you can have an impact on the business, this is very different than a data product, which is at the core of the business. But going back to the job title data scientist, I just want to observe that just because no one was called a data scientist before they made the job title data scientist at LinkedIn doesn't mean that there weren't already people doing those exact same jobs or in those exact same functions at other places, such as Google or Amazon or Netflix. There were people with but they had different job titles like quantitative analyst, statistician, research scientist. But I think that once the title was created, it was a sort of recognition that there was a new function at these types of tech companies. And I just, you know, in particular, Google didn't have the job title data scientist until 2013, but that doesn't mean that Google wasn't sort of ahead in a lot of the innovation with respect to data and technology. So I just also want to, there's this quote by Josh Wills, who's now the director of data science at Cloudera, but who I worked with at Google. He had this sort of famous, or if you've spent time reading about data science, famous quote, person who is better at statistics than any software engineer and better at software engineering than any statistician, which in some ways succinctly describes it. But then I like this quote from Will Sukareski, who countered, he's a data scientist at Kaggle, a person who is worse at statistics than any statistician and worse at software engineering than any software engineer. But so part of my point in bringing up this history of data scientist as a job title, this short history, is that then, you know, in 2012, just about a little over a year ago, DJ Patel, the guy from LinkedIn, wrote this article with Tom Davenport at Harvard Business Review that data scientist is the sexiest job of the 21st century. So then if data scientists, you know, actually had some real meaning prior to that with respect to its origins in the tech industry, once you declare it the sexiest job, then, you know, HR departments across all industries are going to want to start attracting talent by saying that they have data scientist positions. And so it sort of, in some ways, dilutes the original meaning. But so now this is sort of part of the expansionist force with respect to trying to define data science. I also want to mention origins of the term data science, the actual two words, data and science, put together. Clearly, the first time that the words data and science were put together in a term or a phrase, data science, was not in 2008. There's many examples of this, but one sort of more relevant example is that in 2001, Bill Cleveland, who was then at Bell Labs, wrote a very short 6-page or so action plan for expanding the technical area of the field of statistics. The action plans outline 6 areas that university departments in particular should focus on. Multidisciplinary investigation, so statistics applied across different disciplines, models and methods for data, computing with data, pedagogy, tool evaluation, so what tools and technologies should be used to analyze data, and a large portion on theory. And so this is not to say that this is what data science is now, although it could be what it becomes, but it is to say that the term data science existed before the job title data scientist. So that's sort of another force. And there's other examples besides this. And another theme, or the third thing I wanted to bring up was origins of data science in other academic disciplines. But I just wanted to say that this is partially shaped a bit, I want to go a little bit, it's motivated by my being a statistician at Google, and Diane, who I work closely with at Google, will tell you a lot more about Google later in the day. But these are some of the themes that came up for me there. The first is that the sort of cultural clash between statistics and computer science, where I'd say models versus algorithms. So meaning that I think of statistics as statisticians as building statistical models and doing statistical inference to try to find meaning in the world. So for example, logistic regression or linear regression, the parameters in your models are interpretable, and you can tie them back to sort of real world phenomenon. Whereas the very same algorithm or model, like logistic regression, at a place like Google might be used to predict click-through rate on ads, and you might throw in hundreds of variables or features into those models with the goal of building an algorithm that's the best at predicting. And so there's something very different in mindset between building models to understand the world versus building products that have the goal of optimizing some evaluation metric. And I don't think either is right or wrong. It's just interesting that these two sort of philosophies or ways of building models comes together in a single place. And I think they're both part of what data science could be. Of course, being a statistician at Google, there's a lot of challenges with respect to the engineering infrastructure, and you basically had to take on a lot of the skill sets of the software engineer, which is sort of what Josh Will's quote was about. And so you're dealing with the actual raw logs of the data. No one's handing you a clean data set that you can then analyze. You're going into the raw user logs and having to write code to process and clean that data, and then you're also dealing with what happens to statistical models at scale, meaning that you can't necessarily run your models on a single machine. And so that poses methodological and theoretical problems. I think one of the unique things, at the time, one of the unique things at Google, but I think this is part of the tech industry now, is that there's massive experimental infrastructure, meaning that you're running tests at, well, statisticians would call them experiments, but computer scientists might call them A/B tests, where you're running case and control studies on your products and trying to understand the impact on certain metrics that, if you change algorithms or you change the UI, how does this improve the user experience in some way? And I think there's a lot of interesting problems still with respect to experimental design for statisticians, and in particular with networks, because if you are in, especially by which I mean social networks, networks of people, because the assumption of independence of users doesn't hold when you and your friend, or perhaps one is in the case and the other is in the control group, and they can actually influence each other's behavior. So there's a lot of interesting problems around that. But also, I'd say that it helped me understand what I'd call, after being at Google and then talking to actually a lot of data scientists or statisticians and quantitative analysts across the industry and their jobs, I came to understand that what I would call the data science process, where I'd say that, you have the real world and you have the user interacting with Facebook or LinkedIn, let's say, and that generates a lot of raw data, and that's very messy and hard to deal with, and it actually takes about a large portion of your time to process that data and get it into something resembling a clean data set with rows and columns that you can actually then do anything with. And so that sort of skill set is often not taught, at least to statisticians in schools. And so then once you have your clean data, you can it's always good practice to do exploratory data analysis and to really understand your data, and particularly when you're dealing with data generated by logs and user level data, there's a lot of debugging that needs to go on. So you need to explore the data and make sure it was okay. So there's sort of this loop that keeps going on. But once you have clean data, then you can apply algorithms and models. And I'd say I distinguish again between whether you're doing that to build the data products that I described, or whether you're doing those modeling so that you can communicate or report your findings, visualize it, and help people make decisions or publish it in a research journal. So there's sort of two paths I'd say those models could go. But I think it's really important that then once you build the data product, this then gets integrated back into the real world. And so there's this loop that's actually going on. I want to mention too that this whole data science process doesn't have to just be about user level technical data. It could be about someone going and getting their blood drawn, and the scientific method surrounding that. And so it's sort of a general process. But I think I'm focusing right now on what it looks like in the tech industry. But one of the things I wanted to observe was that at least in statistics, there's sort of these classical problems around predicting and causal inference. You can build models to predict, or you can build models to try to understand. And I feel that it takes on new meaning in the context of building data products, causation and prediction, because the models and algorithms that you use to predict end up actually having the ability to cause. And so this is very different than building a model to predict the weather. Even if you accurately predict the weather, you're never going to cause the weather to change. But if you are building a model, to predict whether or not a user is going to click on something, and so you put it at the top of the search result, then you're potentially causing the user to click or to buy or whatever. And so any models that you build need to take into account their own influence on the user. And so I think there's a lot of interesting opportunity for methodological research around this, but it also creates ethical issues that you have to be aware of the impact that you're actually having when you're building products that are going out into society. So I just wanted to give you a little context of what data science meant at a place like Google, but I want to acknowledge, of course, that this just has roots in all other academic disciplines dating back for decades and centuries, from statistics, computer science, engineering, and social sciences, as well as, depending on your application area, other disciplines. But I just want to caution that if data science is ever going to mean anything real, it need not be a bunch of academic disciplines just glued together. I think that the opportunity should be what happens when these various fields intermingle and are part of solving new problems together and new methods. There's data science is starting to get defined as its own academic discipline. Being involved at Columbia in designing the master's degree in data science at their Institute for Data Sciences and Engineering. I just wanted to show you that this is what the course looks like, the course listing looks like. There's a bunch of foundations, and then there's sort of attempts to start creating new courses like machine learning for data science, algorithms for data science, data engineering. It culminates in the data science and capstone project as well, which includes lots of discussion, hopefully, around ethics, and the application areas. The students will work with industry partners. But also, it's important to mention that there's a space for electives where students will have the opportunity to apply these skills, these sort of technological data skills, across all possible disciplines. So it need not just apply, to Google-like data, but they can apply it to biomedical data, genomics, to whatever computational humanities or digital humanities, whatever their specific area is. These fields, these skills are now becoming necessary in a lot of research disciplines. So let me just go back to what is data science. What I wanted to convey to you was that there's multiple forces at play in defining data science. There's the job market, there's marketing and media hype, and Twitter, which is shaping a lot of people's understanding and a lot of the public discussion around data science. There's academia having the opportunity to define it with more rigor. There's real-world problems that actually need to be solved, and there's technology integrating more and more into our culture, and data being generated from that technology. And another force I'd say at play is the people in this room who have the opportunity to help shape and define it. So I'd say, at least right now, data science was a job title, or data scientist was a job title with origins in tech companies, which represented a hybrid set of skills from multiple disciplines. Those same skill set can be used to solve problems across disciplines, and it's agnostic to the application area. While the origins may be in the tech industry and in traditional academic disciplines, it's expanding. But I think that the notion of a data product seems particularly novel, where the real-time feedback loop between humans and machines, or humans and products. And as